With 80 warships, France's navy is one of the most powerful in the world. Its ships are engaged in all theatres of military operation.
The sea is clearly the center of the world. So whoever wants to dominate the land must dominate the sea.
As both firing platform and ship, these vessels contain an extraordinary concentration of technologies.
The warship is one of the most complex systems that humankind is capable of designing and operating.
From the galleys of the 17th century to the armour-plated ships of the Second World War, we'll travel through 4 centuries of history to discover the technologies which today's warships have inherited.
A lot of research was required to obtain a ship capable of functioning well at sea, whilst fulfilling its military role as an artillery platform.
We'll explain why the cannon profoundly changed ships' architecture and transformed the art of war.
A 380mm gun is capable of firing a 1-ton missile at 900 kilometers per hour every 1.5 to 2 minutes.
You'll discover the combat technique of the first warship, the galley.
The strength of the galley lay in its impact.
And how they built genuine walls of wood to protect against cannonballs. You'll understand why warships were slow to adopt the steam engine in the 19th century.
You immediately think steam, that's it. No. Perfecting it took a very long time. It was complicated.
And the reasons why torpedoes and aircraft brought an end to a century of domination by the steel monsters. Welcome to 400 years of history and technology. Welcome to warships. Off the coast of Africa, in the Indian Ocean, warships with futuristic silhouettes are cruising. Among them is the most valuable element of the French Navy, a giant, the aircraft carrier Charles de Gaulle. The ship launches the Rafale into action, the latest generation of combat aircraft.
It's a 40,000-ton ship, which carries around 30 aircraft made up of the Rafale, the Hawkeye, which is the early warning aircraft, and then helicopters to carry out logistics, transport, and to protect the aircraft in their takeoff and landing phases. An aircraft carrier transports aircraft which carry out missions of reconnaissance, no-fly zone enforcement, interception, bombing, anti-ship warfare, everything an aircraft is capable of.
It is the largest ship in the French Navy, at 261 meters long and 64 meters wide. The Charles de Gaulle is the only surface ship with a nuclear propulsion system, which needs refueling just every 7 years. The 12,000 square meter flight deck, equivalent to 2 football pitches, is home to around 30 Rafale aircraft and 1 Hawkeye, and its 2 steam catapults can launch its aircraft in just 15 minutes.
I don't think there's anything more sophisticated than a warship. It's the largest object manufactured, constructed, made by humans that exists in the world. It's a tool that's very expensive to design and construct. It requires a huge amount of know-how in every aspect. It's the most accomplished tool from the technical and technological points of view. You could compare it today to the conquest of space.
Thanks to the aircraft carrier, France can deploy its military power and defend its strategic interests anywhere in the world. No target is out of reach.
The warship is a part of France that can go anywhere in the world. It's capable of cruising any ocean on the planet, reaching every continent, and 80% of the population.
Quand vous avez un porte-avions,
When you have an aircraft carrier, you position it close to the coast. And with your aircraft, you can go a lot further, so you have a much greater ability to strike inland.
The jewel of the French Navy is always accompanied by its escort. A minimum of 6 ships, which make up the task force.
An aircraft carrier is never alone at sea. It's surrounded by a whole armada, which will allow it to escape from submarines or airborne threats, if there happened to be any.
To protect the aircraft carrier, 1 anti-air frigate, 2 multi-purpose frigates specialized in anti-submarine combat, 1 replenishment oiler ship, and 1 nuclear attack submarine, which will be the fighter and protector of the task force.
Danger can come from anywhere, because contemporary naval warfare is in 3 dimensions: surface, air, and underwater. And no ship can defend itself against these 3 dimensions.
While ships join battle today at a distance of over 1,000 kilometers, 4 centuries ago, they confronted each other in deadly close combat battles. One ship was perfectly designed for that type of fighting, the galley. In the 17th century, France had 40 galleys in a corps commanded by a general of the galleys. The corps was made up of 3 types of ship: the ordinary galley, the ultimate battleship; the patron galley for the commanders of the corps; and the royal galley for the use of the king, queen, and royal princes. The ship originated in the Mediterranean in the year 600 BC and was designed for close combat.
The galley was a combat weapon. The idea was to surprise the enemy ships, to sail around them, to surround them if they were isolated ships, and then to ram them. The strength of the galley lay in its impact, because you had to smash into the enemy galley at right angles.
Smashing into the opposing ship meant ramming it at full speed, so the galley was shaped to glide over the waves. The slender hull, 8 times longer than it was wide, offered exceptional hydrodynamic performance. Its low height in the water gave the oars maximum lever effect. Finally, this ship, weighing just 250 tons, had 2 means of propulsion.
Galleys had 1 or 2 masts with triangular sails, and as soon as there was a bit of wind, they put the sails up. But the main characteristic of the galley was the oars, the human propulsion.
An ordinary galley had 51 oars, 26 on one side and 25 on the other. Each oar was 12 meters long and weighed up to 130 kilograms. With 5 rowers per oar, 255 men were required to crew the ship.
They would stand up and use all their body weight, and they would hold their oar, in which there were wooden structures called palements, which they'd grip with their hands, and then they'd push the oar all the way forward and pull it back towards them. And that's how they made the galley advance.
A good rower was a man with big thighs, rather than big arms, because basically it's the strength in the legs, the thighs, which make the ship move faster, and the arms just go with the oar.
At full speed, the galley could reach 6 knots or 11 kilometers per hour, fast enough to seriously damage the opposing ship on impact. While the slender hull allowed it to go fast, its low height in the water meant it couldn't sail outside the Mediterranean.
Galleys stayed close to shore. They weren't sea-going ships. In winter, they stayed in port. If it was windy, they couldn't sail, so galleys weren't used often.
The reason the galley fell from favour wasn't its poor nautical qualities, but its limited firepower.
The problem with a galley was that you needed space for the oars and for the artillery. So the galley's artillery was packed into the bow. When two fleets of galleys confronted each other, they did so facing each other because of their cannons. The idea was to weaken the enemy before close combat.
It was fairly tokenistic, because once you fire a cannon, you have to reload it, and it was very difficult to reload a cannon on a galley.
From 1680, galleys were no longer used in the front line as they didn't have enough cannons. The ship was abandoned after reigning over the Mediterranean for 2 millennia. The firepower of today's warships is impressive, like that of the multi-purpose frigate that protects the aircraft carrier.
The Frem is without doubt the best surface combat ship today in the frigate class. It's able to handle all the current threats with its extremely powerful weapons.
On the sides, two 12.7mm guns ensure close protection. At the stern, two 20mm remote-controlled guns allow automatic firing with target locking by day and by night. More imposing, on the bow is a 75mm gun with a range of 30 kilometers. It can destroy land, sea, or airborne targets. Against aircraft, there are 16 Aster missiles which can reach 3,500 kilometers per hour. Finally, the frigate has 16 naval cruise missiles to strike targets over 1,000 kilometers away. Ship's armament is the result of a long technical evolution. The first cannons, also called mouths of fire, appeared in the 14th century. Made from strips of wrought iron assembled by hand, it wasn't rare for them to explode on firing. So, for a long time, people were reluctant to load these weapons onto ships. In the 15th century, cannon manufacturing methods improved. Made from a new bronze alloy, they became safer and more precise. They were installed in large numbers on sailing ships with high freeboard, or height above the water. Unlike galleys, they had no oars, and so had space for artillery weapons along their sides. So began a new era, that of sailing ships and their powerful artillery, which were to dominate the seas for the next 3 centuries and change the art of war. The history of these warships began in the late Middle Ages.
It started in the late 15th century and early 16th century with the appearance of the galleon, which was very archaic. It was quite a big rounded, bulging ship with castles fore and aft.
The wide decks could take a large number of artillery weapons. However, their weight raised the ship's centre of gravity and destabilised it. The solution was found in the late 15th century with a simple but revolutionary idea: the invention of the gun port.
The gun port was a rectangle of wood, which the shipwrights cut into the hull. When the gun port was closed, you couldn't distinguish it from the rest of the hull. Then in battle you raised this sort of shutter. You pushed the barrel into the hole, loaded the cannonball, and fired.
The introduction of the gun port was fundamental. If the cannons had stayed on the decks, it would have been impossible to increase their weight because of the ship's stability. If you put heavy weights high up, obviously the ship will have a tendency to list or even to sink. Placing the cannons below decks lowered the centre of gravity, and therefore you could increase the weight, and also the calibre of the cannons.
The calibre of the artillery progressed rapidly. In 1638, the largest cannon was a 12-pounder. It fired a cannonball weighing 6 kilos. 7 years later, the 18-pounder cannon appeared, and in 1682, the most powerful piece of artillery was made with a caliber of 36 pounds. This 3-meter-long colossus fired a cannonball weighing 18 kilos over 300 meters.
The cannon alone weighed 3.5 tons. With all the equipment, it was closer to 6 or 7 tons. So it was huge, and that was why 15 men were needed to service each 36-pounder.
Cannons of the same caliber were installed in batteries. The lightest were positioned on the upper deck and the heaviest on the lower deck. Each battery was made up of 2 broadsides, one on either side. At the end of the 17th century, the largest ships had up to 3 batteries, giving them the impressive number of 100 cannons.
As these ships were more stable than galleys, the cannons were more effective. They could fire further and with more precision. They could fire further because they were higher in the water, so that's ballistics. And they could have more precision because as the platform was more stable, they could be aimed more accurately.
Combat at sea was changing. They weren't trying to board each other's ships anymore. They weren't trying to get close to each other. On the contrary, they were keeping at a distance and fighting in what would become the famous line of battle, which developed in the late 17th century and would continue in all its glory until the end of the 18th century.
From 1664, boarding, with its risky outcome, gave place to the tactic known as line of battle.
You had about 40 or 50 ships divided into 3 groups, the vanguard, the battle corps, and the rear guard, which had to fight the enemy in the same way. And the 2 squadrons sailed past each other, then turned around and did the same in the other direction. So you had battles lasting 10 or even 12 hours.
You weren't seeking to systematically destroy the others. You wanted them to retreat, showing that you were the strongest. You occupied that area, and you were sovereign in that particular place.
This war of intimidation involved the most powerfully armed ships, the ships of the line. In the vanguard were the ships with 3 decks and more than 80 cannons. In the middle, the ships with 50 to 68 cannons, and in the rear, those with fewer than 50 cannons.
In the line of battle, you obviously tried to have the ships following each other, with the same nautical performance and approximately the same firepower, so you didn't create a weakness in the line. You need to try to imagine a sort of great fortification in which you systematically placed cannons of the same power.
For the larger ships of the line, cannons and cannonballs combined exceeded 300 tons. That significant weight meant that the design of the ships had to be revised.
If you place a lot of artillery in the hull, what do you have to do? You have to make the hull longer, or else you won't have enough space for the cannons, and you won't have enough space to operate the cannons. So you make it longer. But as you lengthen the ship, you also need to make it wider, because if you make it too long, it will become fragile and will have poor nautical qualities. So you have to increase its width. If you do that, you also have to increase the size of the masts. So you need to find larger timber with a greater diameter.
The French Navy, like its foreign competitors, wanted to construct the best warship. Today, warships go through a long development phase. Armament, speed and maneuverability are considered in response to the needs of modern warfare.
We have very powerful software which allows us to design the ship in 3 dimensions and very quickly to be able to integrate all the equipment and systems on board the ship.
Steel hull, propulsion system, electrical and computing networks are built in at the shipyards. These ships are meticulously assembled using gigantic cranes 104 meters tall, equivalent to a 35-story building, and gantry cranes capable of lifting 300 tons or 15 trucks at the same time. In the 17th century, warships were constructed by hand. It all started with the keel, the backbone of the ship.
Constructing a warship was extremely complicated. You had to create a hull, starting with a keel, onto which you join wooden frames, like the ribs connected to one's sternum.
These ribs or frames gave the hull its shape. It was much less slender than that of the galley, because the builders were looking less for the best movement through the water than the efficient distribution of the artillery's significant weight. In order to erect an impenetrable barrier, the distance between each frame was smaller than the width of a cannonball.
Onto this wooden structure, they nailed the planking on the outside, so very long planks of wood which were placed along the hull from the keel to the upper deck. Inside, there was more strengthening, an inner skin, if you like, called the ceiling, so it was reinforced by planks of wood on the inside.
Frames, planking and ceiling formed a hull, which could be up to a metre thick. That's why it was called the wall. This wall was pierced for the gun ports. They were arranged at an equal distance, 2.4 metres apart. And so as not to weaken the hull, they were arranged in a checkerboard pattern. The position of the gun ports was of crucial importance, as shown by the tragic fate of the Wasser. Disaster struck during the Swedish ship's maiden voyage on the 10th of August, 1628.
The boat was very unstable. The gun ports were too low down, and the water very rapidly flooded into the hull, making it sink very quickly.
That day, the 1,000 sailors on board lost their lives in the port of Stockholm. The sinking of the Wasser highlighted the importance of the height of battery.
This is the distance between the waterline and the bottom of the lower battery gun port. There must be a certain distance, or else the ship will take on water through the gun ports and will end up sinking. So this height of battery can't be too small, but it can't be too big either, or the stability of the ship will be affected. It will lack stability. It won't have a good attitude in the water.
After a year in the shipyard, the hull was finished and launched. The final stage could begin, the fitting out of the ship. This wasn't about positioning the artillery, but rather installing the masts, sails, and rigging. The masts reached 30 metres high, the equivalent of a 10-storey building. To help with their installation, the shipbuilders used a sort of crane called a masting machine.
They had what was called a masting machine, which was about 70 metres tall. It was made up of big masts tied together with ropes, which were made to lift very heavy loads and to install the lower sections of the masts in the ships in the vertical position. Then they added the upper sections of the masts, which were ringed with iron, and then they could add all the sails.
The surface area of the sails determined the ship's speed, a decisive element during battles at sea.
As ships became bigger and heavier, as they carried more artillery, they needed more efficient sails, because the sails were the engine. So they increased the surface area to make the ship go faster. You could divide the sails into two groups. The big rectangular or trapezium-shaped sails were mainly used for propulsion, for speed, and the smaller triangular or square sails were used more for maneuvering the ship.
In full sail, these heavily armed ships could reach 9 knots, or 17 kilometers per hour. That was 30% faster than galleys. It took about 100 craftsmen a year and a half to build these Lords of the Sea. Each ship was unique because the master shipbuilders guarded their trade secrets jealously.
The extraordinary thing about these wooden ships was that the builders handed down their technical expertise through 6 or 7 generations.
The designers of the ships stuck to the tried and tested methods. It's like recipes in cooking. Once you have the right balance, you don't change it. There's the know-how, the knack, all of that.
Whilst the recipes most often produced efficient ships, they sometimes made ships that were incapable of putting to sea. Given their cost, the Navy couldn't afford a failure like the Wasser.
The number of people it took between the master shipbuilders, the shipbuilders, shipwrights, the cannon manufacturers, the foundry workers, the sailmakers, everything you need on a ship, from planking to hemp, cannons and armaments. It was quite extraordinary.
A ship cost £1 million in the late 18th century, which was equivalent to 300 kilograms of gold.
For the time, this extraordinary cost forced France to draw up construction standards that would guarantee the excellence of ships. Arsenals like Toulon, Brest, Rochefort or Lorient played an essential role. They developed new technical solutions and trained the best shipbuilders using extremely detailed models.
These big models, usually 1 to 10 scale, were almost a kind of simulator. You stood around them. You were there to learn. You were there also to see the effect of the wind on the sails. They were instructing the master shipbuilders. So they were a real 3D training school.
In 1765, France founded the School of Maritime Engineering. It trained the future engineers who would replace the old shipbuilders. These men of science used the new mathematics and insisted on drawings. It was the birth of modern naval architecture.
In the 18th century, times had changed. Certain inefficient ships had been abandoned for good, and the 74-gun ship of the line had been perfected. It was the battleship par excellence.
Its name was the Téméraire. It was the first warship built according to a naval architectural plan. The plan was the work of 2 men, Jean-Charles de Borda and Jacques-Noël Sanet.
Borda was the academic, the mathematician, the scholar, and Sanet was the highly skilled and competent engineer who made his career following the training route of the time as a shipbuilding engineer.
Together, they optimized the 74 gunship of the line, conceived 40 years earlier. They found the best compromise between firepower and nautical qualities.
It was the result of a lot of research to obtain a ship that was capable of functioning as well as possible at sea while fulfilling its military role as an artillery platform.
The ship's dimensions were impressive. 57 meters long, 15 meters wide. Its tallest mast was 85 meters high.
When you imagine a ship moored at a quay level with a person, with its banks of sails, it was pretty impressive. If you placed a 74-gun ship of the line with all its sails unfurled in front of the Arc de Triomphe, the arch would be completely hidden, completely invisible.
It weighed 2,950 tons. This giant was powered by more than 40 sails, with a total surface area of 2,600 square meters, or 6 basketball courts. This powerful propulsion allowed it to reach the unheard-of speed of 11 knots, or 20 kilometers per hour. The ship also had exceptional maneuverability, a crucial advantage in battle.
These nautical qualities were desirable because in battle, changing tack was a very complex operation. Tacking took half an hour of maneuvers. assuming that the enemy wasn't firing at you from all directions. So the desire for maneuverability was essential in terms of war.
The ship could change tack in just 15 minutes. That was half the time of its opponents. This prowess was made possible by the addition of one element on the mizzen sail, located at the stern of the ship, the boom.
Gradually, this sail was perfected. The bottom of the sail was attached to a piece of wood called a boom, which kept the sail more rigid. And that was great, because it meant you could trim the sail very accurately and adjust it by a few degrees, more or less.
Fast and maneuverable, the ship was powerfully armed. Its 74 guns were arranged in 2 batteries. In the lower battery, there were 28 36-pounder guns. In the upper battery, 30 18-pounders, and on the upper deck, 16 8-pounders. In the hold, it carried 4,400 cannonballs and 22 tons of gunpowder, enough to last 6 months. This ship was a formidable artillery platform. Sané-and-Borda's Ship of the Line was the centerpiece of the French Navy.
The ship was built according to blueprints which standardized the model. That meant they could develop construction according to pre-established, standardized models, with a ship that would be identical.
In 1 century, around 100 ships were produced in the shipyards. This success inspired foreign navies which sought to copy them.
In the 18th century, industrial espionage was rife. There were British engineers who tried to come to Toulon to spy, and also to Rochefort. This espionage also happened when an enemy ship was captured, so technical knowledge and know-how circulated widely.
These 74 gunships of the line and their variations, the 80-gun and the 118-gun, showed their power by exhibiting their artillery. Today, the stakes are very different. 21st century warships seek to be stealthy.
The object of stealth isn't to make the ship invisible. That's impossible. It's to make it less visible, so that its radar imprint on an enemy's screen looks like a small ship or another ship, rather than a threatening, high-tonnage warship.
On enemy radar screens, the battleship appears no bigger than a fishing boat. This achievement is made possible by the shape of the hull, which is able to attenuate radar waves.
The main means of detecting a ship at sea is radar. The radar emits electromagnetic waves, which will touch the metal sides of the frigate, and this wave goes back to the radar, and the enemy radar gets an indication of direction and distance. The frigate has superstructures on the incline to avoid reflecting the wave, and also completely flat sides, because any cavity represents a sort of cage that amplifies the radar signal and re-emits it with more power, so you can be detected from much further away. So really, thanks to its shape, a Frem today that weighs 6,000 tons is seen as a boat of a few hundred tons that's hardly visible on an enemy radar.
Stealth is a key advantage when ships confront each other without seeing each other. It allows you to strike the adversary before being spotted. But when the battle is a deadly head-to-head, the advantage will be with the one that has the greatest firepower. In the early 19th century, the distance separating 2 enemy ships during a battle was less than 500 meters. At that distance, the only thing that counted was the number of cannons.
At Trafalgar, there were more than 5,000 cannons facing each other. To reach those numbers, you had to wait till the First World War. You didn't have that many cannons, and they were big ones, 36-pounders, whereas on land, Napoleon, in the same period at Austerlitz, probably had 146 cannons, and they were only 20-pounders. It was another world.
Naval warfare was changing. It was no longer a matter of intimidating your enemy, but annihilating him.
Destruction The desire to annihilate one's enemy started to appear in the middle of the 18th century. There were battles that demonstrated how they were trying to sink enemy ships, or even, really, to kill men.
The French fired to demast ships. They sought to immobilize the enemy by aiming at the sails. They made the masts collapse. On the other hand, the English were much more dangerous because they fired to kill. So, they aimed at the level of the ship's rail. The English cannonballs splintered about 1 meter of wood, so the poor French sailors were hit full in the chest or the eyes by these splinters, and the French losses were much greater than the English losses.
In 1779, the English perfected a new artillery weapon which they introduced on their ships a year later. It was called the carronade.
The carronade was a short cannon placed on deck, offering very accurate firing over a short range. It was very destructive. The carronade could easily pierce an enemy's hull, but also fire across the decks.
The carronade, loaded with shrapnel, fired at the enemy decks at less than 300 meters. The results were devastating. The French soon copied it and installed this deadly weapon on their own ships. Whether they were carronades or cannons, a lengthy process was required before these artillery weapons could be fired. First, you had to clean the inside of the barrel to remove any powder from the previous firing. Then the powder charge was inserted. Next, the cannonball, wedged between 2 wads of old ropes, was compacted in the barrel. The gun was moved close to the gun port using a system of ropes and pulleys. 15 men were needed to manipulate this heavy 3.5-ton gun. Once in position, the gun commander would discharge the powder and light the match cord.
I use the example of a Formula One car coming into the pits to change its tyres. You have to be as quick as possible. Loading a cannon was no different. You had a team around a cannon, and they had to react very fast and be perfectly coordinated. And that coordination only came with practice.
The English were capable of firing a 38-pounder gun in 8 minutes. The less well-trained French took 2 or 3 times longer. Once the cannons were ready, the ship's side had to be positioned towards the enemy.
The commander's task was to maneuver his ship, or even his fleet, if he was an admiral, into a favourable position to fire the first shot. And even to be able to fire a second as quickly as possible, in the knowledge that the ships were moving.
When you have about 30 cannons firing more or less at the same time, first of all, it's very noisy, and then there's a lot of smoke. You can't see the cannon next door. The smoke is overwhelming. You have to try to imagine it. There were about 300 men in a space already saturated with gunpowder. You can't imagine what it was like, but it would burn your throat. There was the heat, of course, the fear, the noise of battle and explosions, because opposite you, the enemy was also firing. And when he hit his target of the enemy gun ports, the wood exploded, which sent splinters and particles whirling about the batteries, striking the men. The wounds show this quite clearly.
In addition to the dead, there were dozens of wounded men. So that the crew wouldn't panic at the sight of so much blood, the decks of some ships were painted red.
The English ships had trained crews, used to very strict discipline, and, if I can put it this way, they were replaceable. They had 3 times more naval reserves than the French did. I think the difference in the late 18th century wasn't so much in technology, but in human resources.
With more sailors but also more ships, England had the most powerful navy in the world. France wanted to make things more equal, and in order to do that, invested in technological advances.
The idea was to equal the quantity and financial resources of Great Britain by technological breakthroughs. France systematically used technological innovation to compensate for financial, economic, and industrial inferiority in comparison to Great Britain.
So Henri-Joseph Peixon, an army general, graduate of the École Polytechnique and French artillery specialist, developed a new weapon, the shell gun. Both shorter and heavier, this gun fired explosive shells.
The explosive shell, firstly, traveled faster, so it was able to smash through the wooden walls, and it exploded inside the battery.
It proved its formidable effectiveness in 1838 in the war between France and Mexico.
Using these shells, France destroyed the fortress of San Juan de Ulloa. So every navy then understood the threat to wooden navy ships.
While the Peixon gun was quickly adopted by navies, the same wasn't true of the other major invention that would transform warships, steam power.
There was resistance to change. There was a natural skepticism towards new technological breakthroughs. And you could see that with the arrival of steam. Changes in mentalities, ways of thinking, don't happen at the same rate as technological changes. There can be relatively quick technological changes, but then people have to adapt.
The first steam engine was installed in a boat in 1807. With 18 horsepower, it operated 2 enormous paddle wheels.
The invention of steam power was applied at sea by an American, Fulton, giving more power. And he made the first steamboats with a range that made them useful for trade or for war.
In 1838, an English liner powered by both sail and steam made the crossing from Liverpool to New York in a record time, 15 days instead of the 40 days needed by other sailing ships. In spite of this exploit, the great naval powers were slow to adopt steam.
You immediately think, steam, that's it. No. Perfecting it took a very long time. It was complicated. First of all, you needed different types of people on board. You needed mechanics, you needed people who worked in forges, people in the iron trade.
The steam engine was a complicated and delicate mechanism which raised questions over vulnerability in fuel stocks.
For the military use of steam, the major obstacle was the protection of the ship, because the external wheels providing the propulsion were extremely vulnerable to enemy artillery.
But there was another problem. In the holds, they needed enormous stores of coal. So they not only needed space in the holds for that, which was to the detriment of the cannons, but they also needed external infrastructure, places to pick up coal around the world.
Another revolutionary invention solved the problem of vulnerability, the propeller. Located below the waterline, it was protected from enemy fire. It quickly appealed to naval commanders. Every warship is now driven by propeller. It allows them to travel at remarkable speeds. The problem is that they generate considerable noise, which can be picked up by enemy submarines using their sonar.
They have antennae, which try to detect the presence of mechanical objects, such as boats, among the sounds of the sea. Civilian boats can be detected from far away because their priority isn't to avoid detection by submarines. On the other hand, on the Frem frigate, the hull has been specially designed to limit the noise of water flowing off the hull. The stabilizers have been removed, and a much quieter method of stabilizing the ship is used. The engines obviously have to run, and the pumps cause vibration. All that sound is insulated from the hull in order to reduce the noise emitted by the ship.
Engineers have also worked on the shape of the propeller. Its hydrodynamic qualities make this ship even quieter. It was a French engineer, Stanislas Dupuy de Lome, who designed the first warship in the world to be driven by steam and propeller, the Napoleon. 5 years after its launch, it demonstrated its 500 horsepower in the Crimean War, when the Russian Navy faced the French and English navies.
People understood the usefulness of steam power when the Napoleon gave a tow to the flagship, the Ville de Paris, which wasn't a traditional three-masted ship, so only driven by sail, because there wasn't much wind and the currents were against it. And the British were stuck at the entry to the Dardanelles because they didn't have a sufficiently powerful steamship. It was a brilliant demonstration of the superiority of steam over sail.
This exploit removed the French Navy's reticence with regard to steam power.
In 1855, a committee met and said, a warship that isn't steam-powered isn't a warship. So a page was turned. It didn't mean that all sailing ships were got rid of. But it did mean that people from then on considered that steam was essential to the operation of a warship.
In 1855, a new type of ship was introduced. Continuing its experimentation, France constructed an ironclad platform armed with 50-pounder Paixhan guns. It was called the Floating Battery.
It was called the Floating Battery, as they couldn't call it a frigate or a corvette or anything else, because these were ships with no nautical qualities at all. It was a sort of fortress on water. It was a big ironclad shoebox which fired guns, and that was it. It had no form. It wasn't a ship of the line. It wasn't a ship. Let's be honest about it.
During the Crimean War, 3 floating batteries were towed to face the fortress of Kinburn. On the 17th of October 1855, they reduced the fortress to ashes in 4 hours. For their part, the floating batteries sustained little damage in spite of being hit by 126 shells. This success confirmed the intuitions of the engineer Stanislas Dupuy de Lome.
Dupuy de Lome was a brilliant young naval engineer. He was sent to England several times to observe British technological progress. He was struck by the achievements of the British steel industry, and in 1845 he proposed the idea of an entirely ironclad frigate.
This new type of ship was launched on the 8th of March 1859. It was the first ironclad in the world. Its name was Gloire.
It was a ship that was extraordinarily technologically advanced, such that for about 20 years, France was ahead of England in naval architecture, which was rarely the case. The Gloire marked a break with the past because it was a combination of 3 types of innovation, which were 1, artillery with exploding shells, 2, propeller-driven propulsion, and 3, armour plating.
The Gloire brought to an end 3 centuries of domination by sailing ships, and the age of the ironclad started. These steel warlords would rule the seas until the start of the Second World War. The Gloire was an imposing warship, almost 78 meters long and 17 meters wide. But it was above all a very heavy ship due to its armour plating, 5,630 tons. Plates of wrought iron, 11 centimeters thick, were fixed to its wooden hull. They went all the way round the ship at the level of the waterline. These plates added 844 tons of extra weight. Dupuy de Lome was forced to reduce the weight if he wanted to retain its nautical qualities.
Dupuy de Lome needed to save weight, so the forecastle and the aftcastle disappeared, and you had a continuous deck with all the guns in battery under an armour-plated deck.
Normally, it would have had 2 decks, but with the weight of the armour plating, he had to remove one battery. And that was why it was called an ironclad frigate.
Although fewer than on earlier ships, the guns were much more powerful. The Gloire was armed with 36 shell guns, which were now able to be aimed through almost 180 degrees using a system of rails. In addition to its sails, the ship had a steam engine, which produced more than 2,500 horsepower. With a powerful engine and reduced weight, the ironclad could reach the impressive speed of 13 knots or 25 kilometers per hour. This first ironclad in the world was a successful blend of the floating battery and the ship at the line. Today, the challenge still remains to find the ideal balance between armour plating and nautical qualities.
Armour plating is big, it's heavy, and so it has an impact on speed and range. It's all a matter of compromise. So you armour plate the sensitive parts of the frigate. You can't armour plate the whole of the ship, as they used to do in the past.
The latest generation of frigates have lightweight armour plating, but they're still incredibly strong ships due to their innovative technical design.
The Frem frigate is separated in 2. It's as if you have 2 frigates, one at the front and one at the back. And between these 2 sections of the ship, there's a double dividing wall which isolates the front from the back. If a missile strikes the front, for example, you'll find exactly the same systems at the back, and the ship will be able to continue fighting to a certain extent.
The incredible resistance of today's ships is a legacy from the 19th century. In the late 19th century, ironclads became the capital ships of navies.
The capital ship is the ship around which the whole fleet is organized. The whole fleet exists to showcase this ship, because the idea we have of naval warfare is that the war will be played out at sea in a decisive battle, and from that confrontation, a victor will emerge, and the victor will control the sea.
In order to win the decisive battle, the warring navies engaged in a technological race between armour plating and guns, between shield and sword.
Guns were getting bigger and bigger. You'd have absolutely massive guns which could fire 2 or 3 times in 15 minutes, and in parallel, the protection was increasing.
Steel replaced wrought iron, and the plates became 5 times thicker. The armour plating went up to 1/3 of the total weight of the ship. The problem was that these ironclads were much slower and less manoeuvrable.
One of the solutions was not to armour plate the whole length of the ship, but only the vital parts, to reduce the number of plates to 2 or sometimes 4, which were installed around a sort of fortified castle. That would be in the centre, and you'd have a sort of blockhouse or a dungeon in the industrial style.
On deck, the artillery weapons were first of all protected behind an armour-plated wall, then later integrated into a rotating turret. That technology, perfected by the English in 1869, revolutionized warships.
The invention of the gun turret was a revolution in ship construction which would completely change the appearance of the platforms.
From 1879 onwards, guns were up on deck, and the gun ports disappeared. The form of French warships was getting closer to that of modern ships. All the ingredients were there for the arrival of a new type of ship. But this time, the revolution didn't come from France, but from England, when in 1905 they built the Dreadnought, meaning fearing nothing.
When the Dreadnought came into service, all the ironclads that existed before were named pre-Dreadnought, in order to show that there was a significant break between the ships that existed and this Dreadnought. And the really revolutionary thing about this ship was the fact that it was driven by turbines. and went fast. It was well protected and possessed a uniform main battery of heavy caliber guns.
The English had understood before anyone else that this was the age of big guns, with a range of 22 kilometers. The advantage was that they could engage the enemy from as far away as possible with maximum firepower. The aim was to combat a deadly threat, the torpedo.
Torpedoes in the beginning were really almost homemade. Trial and error. They put an explosive charge on the end of a spar on a small motorboat, and then they sailed towards a big ship to make it explode.
This rudimentary weapon was quickly improved. In 1864, the English engineer Robert Whitehead attached a motor to long tubes carrying an explosive warhead. Undetectable, the torpedo moved along, level with the water, and exploded below the armor plating of the ironclad.
And this threat would be realized, strengthened, upgraded in the 1870s with the introduction of the torpedo boat. The torpedo boat was potentially a deadly enemy of the ironclad. It was a small boat with 2, sometimes 4, torpedo tubes. Very fast, very low in the water, with a small hull. And it would approach ironclad ships very fast, launch its torpedoes, and disappear. The only problem at the time was that no one knew how to guide the torpedoes, so they had to be launched in the right direction. The torpedo boat had to line itself up for a certain time so that its torpedo would go in the right direction and stay in that direction.
The short range of the first torpedoes meant that torpedo boats had to get close to the target. They were therefore exposed to the Dreadnoughts' guns. By 1910, fully automatic gun turrets significantly increased firing rates. The shell was placed in a small hoist with the powder charge, transported to the top of the turret and inserted into the gun barrel. This operation could be carried out in less than 1 minute. These turrets were installed on French ironclads from 1911 onwards. Another important but invisible change took place concerning propulsion.
The question of propulsion remained central, with one major development. First of all, the change from coal to oil during the First World War at the instigation of the Royal Navy. Firstly, it offered the possibility of manufacturing more efficient engines, including diesel engines, and it also allowed faster refueling. Refueling with coal was a dreadful chore, which was simplified by the change to oil.
The ironclad was constantly improving in order to keep its supremacy up until the start of the Second World War.
There was a sort of race to build the biggest ships. Ships became heavier and heavier, more and more imposing. So obviously for their propulsion, they needed boilers that were capable of giving sufficient power to drive the boat at speed.
In 1939, France fitted out its most imposing warship, an ironclad 264 meters long, weighing 37,000 tons, the Richelieu.
Forteresse flottante, navire de bataille dans toute l'acception du terme. Le cuirassé abrite sous les plus épaisses cuirasses l'artillerie la plus puissante. Il doit faire front à tous les assauts et décider du destin du combat.
The ship was armed with the biggest guns ever built by France, 380 millimeters diameter.
You have to imagine that a 380mm gun is capable of firing a missile weighing about 1 ton at 900 kilometers per hour, muzzle velocity, every 1.5 to 2 minutes. The ships fighting each other were getting further and further apart. Between the very beginning of the 20th century and the Second World War, the range of naval artillery increased 6-fold, pretty much. So that allowed ships to fight each other from much further away.
But the Second World War sounded the death knell for these colossal ships. With their undersized air defences, they were incapable of withstanding airborne firepower. At Pearl Harbor, the American fleet was decimated by Japanese aeroplanes launched from aircraft carriers a few hours earlier.
With the use of aircraft later, the question of range becomes less relevant. Actually, the factor that will increase the capacity or the length of the ships will be the range of the aircraft. So you'll be fighting each other at distances much greater than ships were able to, up till now.
At the end of the war, the ironclads were dethroned by the aircraft carrier, which became the capital ship. But what about the warships of the future?
There's a real challenge to plan and design a ship for the next 50 years. It takes time to implement any idea, but especially for a weapon system, to be able to operate within a collection of weapon systems. So the Navy is for the long term.
As both firing platform and ship, the warship is one of the most complex technological tools ever designed. The galley, the 74 gunship of the line, and the ironclad have marked the history of France. The aircraft carrier Charles de Gaulle and frigates are their worthy successors. In the past, fighting was face-to-face, whereas today, thanks to missiles and combat aircraft, it's possible to destroy targets thousands of kilometers away. This incredible evolution isn't about to stop. Already, engineers and officers are planning the warships of tomorrow.